Hello. The purpose of this video is going to show you how to process the data for your phosphoric acid titration curve. So at this point you should have your raw data from your experiment saved. And just to show you the important information that we're going to extract from this graph, I have this table that I made. So if you want to, you can either pause the video and copy this onto Excel, or if you bring up the post lab, it's the same table that you're going to be inserting information on. So you can either have that up and kind of plug in the data as you go. Okay, so going back to the raw data, just like the first video on NaOH and KHP, I'm going to do a couple of housekeeping steps to clean up the data here. So again, the first step is to just adjust the columns. The second step is to get rid of the second derivative columns. Okay. And then the final step of the housekeeping is to highlight all the data, and we're going to trim the values so that it's only showing us two numbers past the decimal. So I go to Home, and then I go to Decrease Decimal, and just keep hitting it until I have all my numbers with two decimal places. Okay, the next step is to create a titration curve, just like we did earlier. So I'm going to highlight for this run right here. I'm going to highlight the columns, just the numbers in them. I'm going to go all the way down until I get all my data. I'm going to go to Insert, Scatter Plot, and now we have a titration curve that has two equivalence points. So the next step is to insert a secondary y-axis on this graph. So to do that, you right-click, you go to Change Chart Type, Combo, Series 1, we want it to be a scatter plot. Series 2, we also want it to be a scatter plot. We want Series 2, which is the first derivative, to be the secondary axis. So I'm going to click that until it gets a check mark, and then I'm going to hit OK. All right, the next step is to give this graph some labeling. So I'm going to go up here to Chart Design, and then I'm going to go to Quick Layout, and I'm going to click the first one. So now we have some boxes to label the axes. The only thing we need to add in is this box to label this secondary y-axis. So I'm going to go to Chart Element, Axis Title, Secondary Vertical. There we go. All right, now to label it. So this is the titration curve for phosphoric acid and NaOH. On y-axis here, the first one, we have pH. On the x-axis, we have volume of NaOH, and it's in milliliters. And then over here, we have first derivative And then finally, what I need to do is to label these series so that we know that the blue one refers to the pH and that the orange one refers to the first derivative. So to do that, you right-click on the graph, you select Data, Series 1, Edit, pH, Series 2, Edit, first derivative, and then hit OK. All right, so our graph is right here. Now this one is a little squished, so I'm going to expand it. I'm going to make this graph a bit bigger. There we go, that's better. And I'm going to move all the way up here just so that I've got my table off to the right and my graph right here, all in the same spot. Okay, now we have two equivalence points. And what we need to look up is, just like last time, we need to find the point that has the highest first derivative for both of these sections here. So I'm going to do this process for this area right here, and then I'm going to do it for this area right here. So if I hold my mouse over the highest first derivative point, you can see that the X value, the volume of NaOH, is 3.46 milliliters. So I'm going to go to my table, and that's going to be 3.46 milliliters. And then I'm going to go back to the raw data, and I'm going to look up 3.46 milliliters in the first column, and then get the corresponding pH. There it is, and the corresponding pH is 5.54. Back to my table. The next step is to calculate the volume at halfway to the equivalence point. So again, we want half of this number equals, click on it, divided by 2, 1.73. So now we need to go back to our column, first column, and look up 1.73, or as close to it as we can get. So we have two numbers here. We have 1.71, 1.75, which are both about the same distance from 1.73. So what I would do in this case, and this may not be true for you, but what I'm going to do is I'm going to take these two numbers, the corresponding pH values, and I'm going to average them. The nice thing about Excel is you can highlight numbers and it will tell you the average. So I have my two numbers highlighted, and if I go down here, you can see that the average is automatically calculated. So it's going to be 2.55. All right, now we're going to go to the second equivalence point and essentially just repeat the process. So over here, this is where the second equivalence point is going to be. The highest point of the first derivative is right here, which corresponds to 6.64 milliliters of NaOH. Okay, we need to go back to the table, look up 6.64. Oops, went past it. 6.64 has a pH of 8.12. Now, the next step is a little bit trickier than in the first equivalence point. Basically, what we need to find is not just half of the volume. What we need to find is the halfway point between the first equivalence point and the second equivalence point. So to do this, what we're going to do is we're going to add up this volume, and then we're going to divide it by 2. So equals, parentheses, this volume plus this volume divided by 2. 5.05 milliliters. So then to get the pH at that number will be the last step. So 5.05, or as close to it as we can get. So we have 5.04, so that's going to have to be close enough, and the pH is 7.35. Okay, and that's how you process the data for each trial. So for the next trial, you're going to need to generate this titration curve for run 2. So you're going to start here, go over, and then go all the way down, and then insert your XY scatter plot.